Now we're going to talk about abstraction. We're going to start with the definition of the abstraction. Abstraction is a concept of object-oriented programming that shows only essential attributes and hides unnecessary information. The main purpose of abstraction is hiding the unnecessary details from the users. Abstraction is selecting data from a larger pool to show only relevant details of the object to the user. It helps in reducing programming complexity and effort. It is one of the most powerful concepts of object oriented programming. Now, that's a big definition, but at a high level, I think that clarifies the concept. Abstraction is all about enabling the user to focus on the bigger picture, the things you want the user to focus on, and hide away the underlying complexity or hide away the code that you have written into separate functions because you want to refactor and keep smaller reusable units of function in there, but do not intend that particular code to be used anyway by the user. Let's start by looking at an example. So we're going to consider a game controller. And in this example, we're going with the Xbox game controller. As you can see, the game controller has a lot of buttons. It has got the X button, the direction arrows, A, B, and some other arrows which are present. Now, when the user presses the X button, internally, there can be a ton of activity that is happening. The controller may be calling, okay, I need to invoke the X function, but I'm going to call the network communication layer to do Bluetooth or a Wi-Fi based communication, connect to the server, do security authentication. Once it is done, then I'm going to send this command out and then probably light or not light the button to indicate what actions were performed. But as a user is abstracted from all this detail. It's a clean interface. They know that they can go forward and press the X button and expect certain action to occur. And that's the magic behind this abstraction. Let's look at some concrete example. Here, what we are going to do is that as we did in the previous encapsulation example, and if you have not seen the video, you might want to check it out. We went forward and defined an interest manager. And if you see, the interest manager has private attributes and then public initializer, one public function and one private function. Now it's intentionally done in this manner so that certain attributes like get shady interest rate is a function which I want to hide from the user. I do not want them to worry about it. Now I go back to my encapsulation class and then when I look at it, I first go forward and initialize it. After initializing, when I call a dot operator on the object and see what options are available, I just see a single function which is get current interest rate. I do not see the other functions like I do not see the attribute for interest rate. I do not see the shady interest rate. I only see the function for get current interest rate and of course initializer because that was also public. The other details are abstracted away from the user. Now we're going to look at one more detailed example to make sure we can put a grasp around abstraction. Now, abstraction very well works with protocols, and protocols are like interfaces which define the contract. So we are defining a computer language protocol, and we are saying that as per the protocol, there will be an attribute for language name, which will have getter and setter. It will have function to do syntactic analysis. Now we are going forward and writing an extension on the protocol. Now, protocol was just like an interface, which is it had no implementation. It just was a contract. Now I defined the protocol, but after I defined the protocol, I want to provide some default implementation for the protocol. And that's also the part of abstraction which you can start thinking if you're coming from other programming languages like Java, which used to have abstract classes. Abstract classes would allow you to have abstract methods and implementation methods so that they cannot be instantiated. Now, the protocol itself cannot be instantiated, can be implemented by a class, but at the same point in time, using extensions, you can provide implementation for some of the methods or some default implementation that you want to. It has a side effect, which we'll cover in a bit. But for now, what I've done is that I defined the protocol, and for the do syntax analysis, I've provided some default implementation. Now I'm moving forward and then providing some concrete implementations on this protocol. So first one is I'm going to write a class for Java, and of course I need to go forward and tell the language name. So I can go for, and again in the protocol it was the variable was not really defined. It was said that okay, it could exist with getters and setters. So I can go forward and define the variable inside the Java class. If I try and go inside the initialize and set self.language name, now that will not work, primarily because the variable name or the implementation is not there. There's just a contract that I have had hand right now, saying that there can be language name with getter and setters, but those that attribute does not exist. So if you're providing implementation, you need to go forward and add the implementation for the language name. And that's what I'm going to do now. I'm simply going to go forward and define the variable language name. And then I'm actually going to go and assign it public so that it's visible outside. As you can see, I'm actually adding all this code in sources under abstraction. And I'm going to actually go to abstraction to see how this code really plays out later. So I went forward and defined the language in Java. Then I went forward and defined another class, Swift. And this time around, I have gone forward and choose the language name as Swift. So far, I'm relying upon the default implementation do syntax analysis. So I was not making any changes to it. But Swift, I'm going to go forward and say, okay, this is my custom implementation, and I'm going to go forward and pass on the language name. So we can see that, okay, there's a default implementation which is present, and there's a custom implementation which is present. At present, I've defined a protocol, I've defined extension, I've defined a couple of classes. I'm going to define one more class for Kotlin, and this one is going to extend Java. So I'm going forward and using the concepts of inheritance as well. I went forward and inherited from Java. So as a result, the language name variable is now already clear. I don't need to go forward and redeclare the variable language name. It's already present. I can go forward and define my initializer, but the default initializer, which is init itself, is always present. So if I want to write my init method now with no parameters, since Java will be assumed to have that, I need to use the override keyword to actually define a new initializer in the child class. I then go forward and call super.init so that Java's initializer gets called and then change the language name from Java to Kotlin. And I had to do this exercise primarily because I want to change the language name. Java is always going to assume the language name is Java. I cannot go and redefine the variable, so I needed to implement the initializer to go forward and define the variable name. Here, I'm not really changing the method do syntax analysis. Now, let's go forward and execute these methods which we have written. The first one, I call syntax analysis on Java object. So I see that as soon as I execute the do syntax analysis on the Java object, it will go forward and say this is my default implementation for Java. Then I went forward and executed it on Kotlin. So I got my default implementation for Kotlin because there was no custom implementation provided so far. Now I went forward and implemented a custom implementation. So suddenly the code or the output changes to say that this is my custom implementation for Kotlin. And the same thing is true for Swift as well. All as we would have expected. We go forward and instantiate objects of specific classes, Java, Kotlin, or Swift, and then call the appropriate method, even though Java did not have the implementation, but it was implementing a protocol, and the protocol was having a default implementation to synthetic analysis. So that's what we were able to see when we went forward and ran the implementation. Now I can go forward and add some specific function, which is only true for Swift, and it's function again, do something specific to Swift, and I'm just going to print statement saying I'm doing something very specific to Swift. I'm going to go forward here and add the same function for Kotlin, just like I did for Swift. So I'm doing something very specific to Kotlin. And now what I'm going to do is that I'm going to come and try and see what are functions are actually visible. Now, quick thing to note, in the playgrounds, when you're dealing with sources are supposed to be the compiled units of code that are compiled when you edit them, but they are not recompiled every time to make changes to the playground files. Like if I go forward and change abstraction, they will not recompile. Now within the same file, because all the classes are packaged in the same file, you have much higher visibility. These are functions which are present, but now Swift really does not is going to show you all the possible options, or is going to keep showing you all the possible options as we define these variables, because they are all present in the same file. I go forward with try to go forward with a more slick example where I'm defining a variable, but instead of defining it of type Kotlin or the concrete class, I have went forward and decided to simply choose that I'm going to define of the type protocol. So all good and dandy, I've defined it of type protocol, And at this point in time, ideally speaking, these methods that do something for Kotlin, do something for Swift, should not be visible. But these are visible. And the reason is that because all the code is in the same file. When you're playing with the playgrounds, what you want to do is just remove this, have all the classes and protocols defined under sources. But the actual invocation, if you really want to test how to play in the real environment, you want to do it in the playground files like abstractions, which is outside. Alright, so here you are again, just to re-show all that pieces of the code are actually present, and they will show as visible because everything is the same file. But again, I've gone forward and provided the right access specifiers, public and privates. So all is good there. Now I'm going to go forward and move the pieces of code, which is extensions, classes, and protocols, inside the sources folder. So inside sources, I'm going to go forward and say computer language or Swift, go forward and copy paste the entire code base there. And of course, I do not want the implementations to be invoked from here. So I am going to go forward and remove those lines of code. Now it has got all the class definitions, so all the blueprints are present there, but the actual object is instantiation. Again, going to OOP concepts, the blueprints are present in my computer language.swift file. And in the real world example, I will probably put all the blueprints in separate files. So like I will not try and merge everything into a single file. I will probably put the different classes in different files. But now I'm going to go forward and in my playground for abstraction, use these blueprints to actually go forward and instantiate the objects. So I'm going to go forward and define my initializer as public so I can go forward and invoke it wherever it is not public. Now I go back to my playground, and once I go forward and go back to my playground, I should be able to see the initializer or default initializer for Java and Kotlin to get invoked. Now, the Java one is complaining because in Java we really did not define an initializer. We simply went forward and said public var language name as Java. We never really defined initializer, so it's going to complain. I will have to go forward and define it if I really want to make it public. Otherwise, it's not public by default. And that's the example which I wanted to demonstrate. Now I went forward and made it public, so everything runs as we would have expected. But now let's try and press Kotlin dot and check. I see language name. I do see do syntax analysis. I do not see the function call for do something which is Kotlin specific. And the reasoning is here is that because I'm working with the protocol, the Kotlin variable is of type computer language protocol and not of type Kotlin. As a result, it just has a visibility, or we have abstracted most of the concepts for Kotlin to the point that you only have visibility into whatever the protocol defined because it's of the type protocol. It cannot have visibility into the specific methods, even though they were public, that were available for a child implementation type because they did not define it as of type Kotlin. Now, going back, one thing which you need to really understand is that when we executed the piece of the code, we saw that it went and said, okay, do syntax analysis. And when it does that, then, and we call it on Kotlin, right? And even though I'm actually going forward and instantiating it of type Kotlin, and this is saying that this is my custom implementation, but I'm actually getting the result as this is my default implementation of Kotlin. And the reason I'm getting default implementation instead of custom implementation is because protocols can be implemented by classes which support inheritance or structs which do not support inheritance. And because of this situation where um, structs cannot support inheritance, doing a dynamic dispatch to figure out whether there's a child which is overriding that particular function is bit redundant. So as a result, protocols do not try and do the dynamic dispatch. Uh, so when you went forward and defined the variable of the type protocol, it's not going to try and do the dynamic dispatch. It has a default implementation which is available in the extension. It's going to use it, and that's what you see. This is the default implementation instead of this is the implementation for Kotlin. This is a bit complicated concept, but again, protocols can be implemented by structs. Structs do not support inheritance, and that is why dynamic dispatch is not done. The default implementation will be picked up. While if you instantiate to an object, then yes, inheritance is taken into consideration. And that's